a while ago, I will be able to discuss and share information about chemical reaction engineering and chemical reaction kinetics. It's just the same, okay? I think to those who are not familiar with this topic, okay, in here, in this particular topic, we will remember the basic types of chemical reactions, okay, in which I discussed already, right? And also we should know the redox, okay, the balancing of the number of atoms in the reactants and in the products, and then you have to balance the number of electrons, okay, the charges, then we determine the oxidation state, something like that, okay. This may be helpful also, okay, but not so much in that. The more important is to learn also the uh, radiography process or radioactivity, right? The radiation processes, okay? The alpha ray, the alpha emission, okay, the alpha decay, or any radioactive decay of nuclei atom, okay? If you remember those three, right? The alpha, the beta, and the gamma. Okay, you have also to take note that one. And then also a little bit of half-life reaction also needed here. But don't you worry, we will not be able to go to the most complex discussion, okay? So me, honestly, really, this is one of the difficult subjects in Bachelor of Science in Chemical Engineering, okay? I don't think so if this subject is also a part of BS Chemistry, but I doubt they have also this subject, okay? Any BS chemistry students there, you have this subject, chemical reaction kinetics or chemical reaction engineering. Of course, it's not engineering anymore because they are not an engineering course, right? This is, they are taking BS chemistry. Okay, like that. So we don't have to touch particular reactions at this point in time. This is only overview, okay, like that. And we need to understand the basic foundations of rate law of chemical reaction, rate law of reaction. Actually, rate law of reaction is just equal to rate law of chemical reaction, or is just equal to rate of reaction. There are a lot of terms for that. The important word to remember is the rate, R-A-T-E. And we take note that if it is a rate, it should be with time in the denominator. Okay, for example, moles per second, moles per hour, something like that. Okay, so this is gonna be the rate. Remember that always rate should have always the accounting of the time it takes for the original reaction to proceed the chemical reaction from reactants to the products. Okay, conversion of the reactants to the products, like that. So this is what we call a rate. Okay, and we need also to know about the method of initial rates. Okay, of course, if there is an initial rate, we have also the final rate. But here we are focusing more on the initial rate because in this topic, chemical reaction kinetics, we are more focusing on the reactants. Okay, like that. And we also know the definition of the overall reaction order. Okay, reaction order in, let's say, element A, element B, or should we say concentration A, concentration B. But in here, we start to the variable first, or hypothetical examples. We don't deal with exact elements at this point in time. Okay, normally gases. Okay, in the situations, normally gases. Okay, but in here, we will be having variables, the X and Y, the B, the C, the D, variables to consider first. And then we need to introduce so that we can understand further before going to the most difficult and complex chemical reaction engineering uh, examples. Okay. Again, as usual, I will be able to get a blank sheet of paper. Okay, my timer starts now. Oh my gosh. Okay. Okay, but before that, let's talk about a little bit of half-life reaction because this is also considered a little bit in studying of chemical reaction engineering. So to tell you honestly, before taking up chemical reaction engineering and chemical reaction kinetics, okay, this is the same. That's only the descriptive title of the subject. Okay, you have to finish all your general chemistry, okay, 1 and 2, both laboratory and lectures. Okay, before proceeding this one, because these are the prerequisites, because you need to understand different type of chemical reactions, the rate of the chemical reactions, the principles of the law of conservation of energy, the law of conservation of matter, the law of conservation of mass, right? So we need to have thorough basic foundation and knowledge for the general chemistry. Okay, not so much with organic chemistry. Okay, but it's more advantageous if we learn also a little bit of organic chemistry. It could be applied also in chemical reaction engineering or chemical reaction kinetics. Okay, so we are now on the chemical reaction engineering. Actually, this is not my favorite subject, or this is not my favorite subject, by the way. I don't like, because this topic really requires a lot of data analysis through experimentation, and then data 1, data 2, data 3, data 4, and this data will be used in your rate equation, something like that. Okay, rate law of chemical reaction or rate of reaction, something like that. And sometimes you'll be a little bit confused if we try to match up with complicated elements, okay, particularly gases, okay, and then sometimes if you will not have an adequate knowledge of course, the balancing of chemical reactions, sometimes you'll be lost also, okay, especially the ICE method, the initial, okay, and then the change in the concentration and an equilibrium. Okay, remember that one, an equilibrium constant topic, or equilibrium chemical reactions also, and then the idea of equilibrium constant is very important here also. Okay, the solubility product constant, the KSP, okay, the equilibrium constant because of the concentrations of the product over the concentrations of the reactant, okay, raised to the number of moles, something like that. It's just basically the same here, but it's gonna be a little bit of experimental, okay, and then we have to discuss this clearly, the most basic one. Even up to now, I cannot really, understand thoroughly this subject. I have only, I think, 60%, but not really that 100%, even though I am already a licensed chemical engineer, but still I have confusion. Okay, and though my chemical engineering is my highest score in the board examination, which chemical reaction engineering is also a topic there, but this is not really my masterpiece and my expertise. Okay, I am more on the organic chemistry, biochemical engineering, biochemistry, or the general chemistry. I am not more on the calculations because as I said over and over again, I'm not good in mathematics. Okay, like that. But I can manage through practice problem solvings. Okay, but it's not really enough. Okay, like that. Okay, chemical. You know what I mean? So chemical reaction engineering. Okay, the word reaction sounds interesting, right? Reaction, oh my God. You have to interact with people, so there's a reaction behind it. Okay, then if there is party A, party B, party C, then you have to react between those parties, and it's very interesting. Okay? Then if you have a girlfriend, if you have a boyfriend, then you have to interact with them also to maintain your relationship, okay, for a long period of time. It's just like that, the chemical reaction engineering, and you have also to establish factors that affect those individual relationship between your boyfriend, between your girlfriend, something like that. So these are also having factors in chemical reaction engineering. For example, the temperature, the pressure, the concentration, right? The catalysts, or any other factors affecting the chemical reaction engineering principles or whatever. Okay? So, like that. Okay, chemical reaction engineering. Okay. Or chemical reaction kinetics. Shout out to Engineer Concordia Bacalso, our mentor in chemical reaction engineering and chemical reaction kinetics. Hi, ma'am. I'll be able to share information regarding chemical reaction engineering and chemical reaction kinetics. Okay, this is for vlogging only and live streaming only. Then if you are watching right now, please correct me also. And shout out also to my classmates, Engineer Timoteo Idolantes, Engineer Ivy Adlawan, Engineer Rio Merel, okay? Engineer Nino Chan, okay? Engineer Stephen Flores, oh my gosh. Engineer Rainier Estrada, Engineer Rainier Danilo Gregory Daclan, oh my gosh. Please correct me if somewhere along my discussion I have inconsistencies, okay? And also our head of chemical engineering department in Cebu Institute of Technology University, Engineer Amis Pakamalan, okay? So this is not perfect, but I'll try my very best to explain gradually and smoothly based only on my little understanding of this main topic, chemical reaction engineering and chemical reaction kinetics. Okay, so we'll start now with a data analysis. Okay, because as I told you earlier, this chemical reaction engineering have data, okay? Data to prove your calculations. It's not enough to balance the equation, the number of atoms of the reactant, the product, the charges. It's not like that. Okay, it's always a rate, as I told you a while ago. Okay. Okay, my gosh. So what is a rate of law of chemical reaction? Oh my gosh. So this is basically the equilibrium constant or the rate of equation constant, okay, multiplied by the concentration A raised to the power, shall we say, X, multiplied by concentration B raised to the power Y, something like that. And this X and Y are exponential, okay, meaning to say this is really through data in our experiments, okay? So it's gonna be the rate of law of chemical reaction, or rate of chemical reaction only. So let's represent this in ways. Okay. R. Other textbooks are using small r, and other textbooks also are using capital R. It's up to you. Okay. R is equals to K, something like that. And then capital A raised to the power X, Y raised to the power, B raised to the power Y. Okay, this is our reaction. Okay. Rate represented as a small r is equal to small k, which is the rate equation constant or rate constant. Okay, and then times the concentration capital A, rate of concentration capital B. Each exponential x and y, okay, are the order of reaction. Okay, reaction order in concentration A is x, reaction order in concentration B is y, like that.
So if we say, what is the reaction order of concentration A? Okay, it's the exponent x. It could be 1 up to 9. It depends on the problem. Okay, the same thing also with the concentration B, y is equal to 1 to 9. It's always B, a numerical figure, a whole number. It should not be a point, okay, because it's more complicated to deal with that. Though I think having also, but it's avoided to have a point something like that, okay. So it should be a whole number preferably. Most of the times, I think so. Okay, that's the y. So meaning to say, that is the reaction order in concentration A, x. Reaction order in concentration B, that is y. So we can say now, the overall reaction order will be the sum of the reaction order in concentration A plus the reaction order of concentration B. So that is our overall reaction order, or shall we say small letter n. We will signify, or we'll have to denote that as small letter n. Okay, don't you worry, n is the number of moles, but in this special topic, we will be able also to denote that as small letter n. Okay, this is the overall reaction order. Okay, like that, because it's very important also in a problem solving, specifically in chemical reaction kinetics or chemical reaction engineering, that the problem will ask you, what is the overall reaction order? Okay, what is the reaction order of reaction concentration A, concentration B? Then you need to know that. Sometimes a question also like that. Okay, and then you have to know that also. I discussed that already very clear, right? Overall reaction order. Okay, like that. Okay. Now, this equation that has an exponential in form, this is derived from the linear equation that goes like this. Okay, like this. X times A plus B, y times B is equals to C, something like that. This one. Okay. Okay. And then algebra, right? X times capital A plus, okay, y times B is equals to C. Meaning to say, this is the reaction order X of concentration A plus the reaction order Y of concentration B is equals to C. C is the product. Okay, we denote that as C to make it easier. Okay, nomenclature only, symbol, or shall we say only, an acronym like this to identify easily. Okay, our formula for this. Okay, like that. So we have also the method of initial rates. That is a method of determining the reaction orders, something like that. So method of initial rates. Okay, so we have now the overall reaction order. It is the sum of the exponents of the concentration term in the rate of the equation. Okay, rate equation or rate law of chemical reaction. So that's all you have to do, guys, is to master the terminologies, because we need to use that interchangeably. Okay, that's the technique in not only in chemical engineering, also in other engineering disciplines, right? Because there are similarities, but the same meaning or the same thing only. Don't be confused if the other terms will be used like that, then you'll get lost, something like that. Okay, so it's just the same. It could be the rate of law of chemical reaction, rate of chemical reaction, something like that. Rate equation chemical reaction. It's just like that, right? As long as we know that that is a small letter R, okay, rate R, something like that. And through this chemical equations, we can understand. Okay, like that. Now, charot. Okay, we go now to the examples, specific examples. Okay. Okay. Now, if, for example, I am in the laboratory, I do analysis, something like that, and I have the concentrations of various, chemicals, okay, and I prepare that one, okay. I know the concentration in molarity, the moles per liter, the rate. Assuming that I know everything, the rate and the concentration, I put that and tabulate that here because this is not a laboratory, this is only verbal explanation to all of you. Okay, so that's why I told you a while ago, or so many times, better also to vlog and live stream in actual, inside the laboratory, and we should, so that you can easily understand what I'm talking to. Okay, but here it's just only, an information, a theory, like the basic foundation, the basic knowledge. Okay, sometimes we need to back up with actual applications so that, it can enhance our knowledge to the specific topic. But since I have no time for that, okay, and I don't think so it's allowed also when you are working in your company. I don't think so because that's your personal, right? So it could be that you have your own laboratory in your home. It's okay, I think so. In your break time, you can do that. But I think it's not also, approved that you can do that because it's against the policy of the company you're working with. Okay, I think so. Okay, because that's your personal thing, right? So it's gonna be, you have your own laboratory to explain that. Okay, you have to do the analysis, the experiments, and you have to discuss properly so that the students can understand. Okay, theories back up with actual experimentation. Okay, but here only pure discussion and theories. Okay, like that. But assuming I already obtained the data, after my laboratory experimentation. Okay, my gosh. Okay, now we have, for example, capital M as our molarity, right? Capital M. Ganon. Gosh. This, please correct me because this is more on algebra. Okay? Algebra and then a little bit of differential calculus. Okay? But I'm not really that good, okay, in that kind of, subjects. But correct me if I'm wrong, huh? Please, please, please. Okay? Mathematical operation. Oh my gosh. M stands for molarity. Okay, moles of solute per letters of solution. Usually, it will be write as capital M directly. Okay, especially if you are BS Chem students, chemical engineering students, no need to, to state that specifically. It's understood to be a concentration or a solubility. It's a solution with solvent and solute. Okay? Like that. So, others also representing a small letter m, but since it will confuse to the molality, okay, which is the moles of solute per kilogram of solvent, something like that, then you have to write that in a capital M. Okay? So, since this is chemical reaction engineering, so we need to say this, reaction or concentration A. Okay, or concentration A na lang siya. Okay, ganon. Okay. So, we start with our first data, 1 molar. Okay. Then 2 molar, 3 molar. Okay, and then we have our rate, corresponding rate for this. Okay. Actually, you should also do the, understanding between the capital R and the small letter r. But we should be consistent in our discussion. Since I am using the small letter r for the rate of the reaction, then small letter r. Okay? It could be also capital R if you want. Okay, this is R. Let's say 0.01, 0.02, 0.03. Okay, and this R, as I told you a while ago in the introduction of this discussion, that this could be rate. Okay, so moles per seconds, assuming. Okay, it could be also moles per hour. It depends, moles per minute. Okay, this is only for the sake of basic discussion. Okay, and here's the moles per letter. Okay, like that. And then we have also another, this is a set of examples. We have the molar, capital M, okay, represented as concentration A. It's just totally the same, right? So 0.1, 2, 3. In the first experiment, 1, Second experiment 2. Second experiment 3. In the first experiment, okay, we obtain a rate of reaction of A, which is 0.01, and the second 0.02, 0.03. Okay, the rest will follow. Okay, and now we go to B, concentration B, something like that. Oh my goodness. Again, R, small letter R. Okay, starts with 1. Okay, 2 molar also, and 3 molar. But through the experiments we obtain, not similar with the concentration A, our R will be, let's say, example only, 0.01, 0.04, and 0.09. Okay. Let's just prove this equation, this one. Why we come up to this? Let's prove, okay, and derive this equation, why it appears to be like this. Okay, where did you get this law of chemical reaction equation, or rate of equation? Okay, like that. So it should be justified through understanding, through data experimentation. Okay, something like that. Okay. Okay. Now, so we need to, actually this is more on analysis. Oh my gosh. Okay, so we have the A. So if we increase, take a look, if we increase this by a factor of 2, so this will increase, of course, from 1 to 2, right? It will increase like that. Arrow up, ha? The same yung sa, sa oxidation number, we need to do the arrow up, blah, 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 okay? Arrow up, okay? So, A increased by 2, okay? So, if we increase our concentration A by 2, if you take a look also to its corresponding moles per second or rate of concentration reaction A, so it should also times 2, because 0.01, 2.02. Take the difference, okay, the gap. So it's also times 2. So small letter r times 2. Okay? And then second. Okay? Concentration A, okay, increased by 3, because this is also 3. Okay? If you start with the initial, okay, concentration, then you also go to the final concentration. It's gonna be like that in your chemical reaction. Okay, initial, final, initial state, final state, initial stage, final state, something like that, so that you can establish an equilibrium concentration reaction, which is the basis for law of conservation of energy and law of conservation of matter. Okay, in chemistry. Okay, like that. Okay, so increase by the factor of 3, and then small letter r, okay, by 3 also. Okay. Okay. Okay, like that. Increase by the factor of 3, by factor of 3 also. Take note the gap, because if the gap is not also equal, and then it's not, you don't have to multiply with the factor of that particular situation. But in here, it's gonna be like that if you take a look with the data. Okay. Now, algebra. Ito na. Charot! My gosh. Hello guys! That's why that's why also algebra is a prerequisite of all your chemistry, right? And also in your higher science subjects, because this is really, applicable in your higher chemistry, in higher subjects. Okay? Like that. Oh my god, my goodness. Okay. So, if you let X as a reaction order in concentration A, so 2 raised to the power X, then 2 raised to the power like that. Okay? Algebra. 2 raised to the power x, which is your unknown. This is the exponent, or the reaction order is equals to 2. Okay, since you let this as an x, this one, what I told you this one, this is same as 1. If no putting of number, that is also 1. Okay, like this. 2x, oh my gosh, is equals to 2, 1. Now in algebra again, if this base are common, you have to cancel this out. And all your exponent equate that. And then the value of x will be solved automatically without question. Okay? Cancel the base 2 like this. Okay? Oh my gosh. So x is equals to 1. Like this. Okay, that's in case of from 1 to 2 molar and from 1.02. Okay, now in the second equation, let's label first equation, second equation, third equation, fourth equation. That's really the format or the technique in solving problems, right? Equation 1, equation 2, equation 3, equation 4. Then you have to correlate each equations so that you can obtain your own formula. Okay, something like that. Because sometimes also in different topics you don't have that specific formula, and through your ideas and then thorough knowledge of each formula, then you can formulate your own formula. Especially in the board examination, there's also a lot like that. You have to make your own formula. Okay, especially in the chemical engineering part. I think in the second day or third day, something like that. Okay. Number 2, do not rely with the formatted formulas in the books. Okay, because they are also person. Okay, scientists are also persons. You are also a person. If they can make it, you can also make it. Something like that. Okay. There's no such difficult thing because we are all individuals. Okay, if they can make it, we can also make it. Something like that. Okay. That's why when you will be able to talk the PRC board examination, your aim must be top-notcher. Okay? Nothing else. So that you will pass. Okay? Higher. Aim high. Okay? Like this. Okay. The second equation will be like this. Okay, here. Focus here. Okay? A times 3, 1, x times 3. Then copy and write that down here. Transfer only, right? Okay. My goodness. Okay. This is 3 raised to power, okay, x. Why x, Sir Sotero? Because we are still on the A concentration. If we refer this original equation here in the rate law of chemical reaction, A is still x exponent. And then we have a series of data experimentation. That's why we need x, dependent of how many experimentation you conducted in the laboratory. Something like that. Okay? So 3x is equal to, 3. I will tell you something later, why it goes like this. We need to really understand, why it's equal like that, okay? 3 raised to the power x. Again, the base is still 3. It's the same. Automatically cancelled. Left and right. Sorry for my tongue. Okay. Automatically cancelled. So, okay. X is equals to 1. Take note. X is equals to 1 for this series of 2 to 3 molar and 0.02 and 0.03. So, constant. Okay. For concentration A. So, X is equals to 1. Okay, now we can write the rate of chemical reaction. So, small letter r, consistent, so is directly proportional to the concentration of A raised to the power 1. Sir Sotero, why raised to the power 1? Because you already compute the reaction order x is equals to 1. And basing in our general standard formula, your reaction order exponent x is here. So we solve for x. So we solve already the value of x here, and we already obtained that one through a series of data experimentation in the laboratory. So x is equals to 1. So rate is directly proportional to the concentration of A raised to the power of 1. X is equals to 1 based in our computation using the foundation of understanding of algebra. Actually, linear equation. Something like that. Okay, so this is our equation 3. Something like that. So if we obtain a series of equations after our derivation, we need to level 1, 2, 3, 4, 5, 6, up to how many times? As long as you will mark that one so that to avoid confusion. Something like that. Now, we go to the concentration B here. We now refer to the data obtained by this experimentation processes. Okay? Now, again, representation of arrow up and arrow down. Okay? We have arrow up because it's increasing, arrow up. No need to, to dig deeper. Okay? Like that. Okay. From 1 to 2. You mean from 1 to 2, my friend. Okay? The multiplier, the capital M, the same as A here, M, okay, it will multiply by a factor of 2. Okay, so capital B or concentration B is equals to times 2. Now, go to the rate of the reaction. That is 0.01. So you have no need to multiply by 2. Why? Because it's go directly to 0.04. So, multiply by a factor of 4. Okay, so R times 4. Okay, that is considering the 1 and 2 and the 0.01 and 0.04. Now, if you consider the 1 and 3 and 1 and here also 0.01, 0.09, that is initial and final. Okay, now arrow up B because we are now in concentration B, something like that. So from here to here, the gap is you have to multiply by 3, right? So by 3. All you have to do have a clear eyesight on the numerical data after your experimentation, data analysis in the laboratory. Something like that. Because in chemical reaction engineering or chemical reaction kinetics, you have to have the data really to solve for the value of R, to solve for the value of K, rate equation constant, and then to determine the reaction order, overall reaction order, something like that. So this is very, very important in nuclear reactor. Okay, to formulate a nuclear reactor, to design a nuclear reactor, you must know this principle. Okay? That's why we have nuclear reactor, but not so much in the Philippines. We don't have nuclear power plant, I think so. Okay, but other countries such as Japan, okay, first high-class countries, okay, like that. Socialite country, type A country, okay, class A countries have nuclear reactors, okay? But I don't think so in the Philippines because we have actually that one during the regime of Ferdinand Marcos, but the anti-government object that one. I think that was in Bataan. They don't continue that one. Okay? I think so. That's the principle of chemical reaction engineering to be applied, and that principle of nuclear chemistry also to be applied, supposedly. Okay, now, for the small r, okay, now, initial and final rate a reaction, then you have to multiply a factor of 9 because it's obvious, okay, by looking at it, okay, so R times 9. Again, algebra, linear equation. Ganon siya ka-detalye so that students can understand very, very well. Charot. Okay, now, so the same method, okay, but this way of discussion really takes time too much, and I think if you will become a professor or in a certain universities, you don't have to do this. You have to take a fast discussion because your time will be limited to 1 hour only, and then there's another another set of students who will be able to discuss them also. You have to make sometimes a direct or shortcut method, But we should not forget the very, very basic foundation of your core foundation of your discussion. Okay? Because, it might vary during the actual situation of becoming a mentor and a professor in a certain universities or institutions or whatever schools that you'll be, or universities that you'll be able to teach someday, something like that. Okay? Okay. Now, going back. So, okay. Referring to concentration, we have, okay. 2 raised to the power x is equal to 4. Again, algebra. Even after maglibog ko, pero I'll try to manage on understanding it a bit. Okay, but correct me if I'm wrong. I'm very, very consistent. Correct me if I'm wrong. Okay, especially, engineering students right now in front of me listening. Okay, especially first year students, engineering students. Okay, because I taught chemical engineering 20 years ago, 25 years plus ago. Okay, and I am only referring to my, stock knowledge and a little bit of research, research, and a little bit of reviews, something like that. Okay, but I think it's not enough because it's not thorough. Because I'm working, okay? I'm not full-time doing this, sharing of information also. Okay? Correct me if I'm wrong, huh? Okay, so, the base is, let's go back to the least common denominator. Again, in algebra, right? LCD. Okay, least common denominator between 2 and 4, it's 2. Okay, divided by 2. Okay. 2 divided by 2 is equals to 1. 4 divided by 2 is equals to 2. So, your linear equation becomes simplified. Because this is the first technique in solving equation. You have to simplify first to avoid complication to your equations. This is the best thing to do. Okay, simplified first. So that you can, simplify the variables, the numerical figure, whatever, chuba chuchu. Okay. Now, okay. So, 1 raised to the power x. Oh my gosh. 2 raised to the power 1. Oh, di ba? Okay, like this. Now, oh my gosh. The x is in the exponent. Again, algebra. Okay. This will be multiplied both by 1 over x to cancel the x here on the left. And both should be multiplied, okay? Of course. So, if multiplied by 1 over x, it will be cancel the x, so it's equal 1 in the left side. And then we have 1 over x. Nako. 1 is equals to 2 over raised to the power 1 over x, exponential or fraction. Andito na naman tayo. Okay. Now, okay, so we need to break down to solve the value of x. Okay. 1 is equals to, this x also can be written as, okay, x square root of 2. Okay, because this is also the same as 1/2. When you raise the number to 1/2, that's square root, right? But that's the basis, not only to numerical figure fraction, but also to involve variable. That principle will be applied also. So you have to do this x square root of 2. My gosh. Ganon. X square root of 2. Right? Now, again, multiply this both sides with 2 to cancel the square root. What will remain is the x. See? Kakaloka. Okay. 2. Then, 1 raised to the power 2 is equals to 2x already. Like that, okay? X cancel and 2. Okay? Like that. Okay? So, 2 to the 2x. Okay? like that. So this is 4x and 1. Okay? Like this. Okay? Take note of the reaction, because this will not be cancelled. That's why, that's the story behind. Okay, like that. Okay. Now, solve for the value of x. Okay. So, 2, 1 times 2x. Okay, like this. 2, 1, and 2x is 1. Because in algebra, you have to, if, for example, this is xmn. You remember that one in algebra? If this is xmn, you have also to say xm and xn. Right? So, like that. So this is, okay, so 2x, 2, 1 cancel, so this becomes our x. Okay. And this is x, 2, 2. Okay. So, cancel also 2. So x is equals to 2. This one. Okay, so x is equals to 2. Okay? Go over to this equation and solve by yourself. We can obtain the same like this. X is equals to 2. Okay? You understand now? Algebra. Anyway, also I'm confused a little bit, but just govern with this x raised to the power m and n like this. And then the other side also will be like this. Okay? 1 raised to the power like this. Okay? And x. Ganon siya. Okay? Since x is equals to 2. Okay? So, x is equals to 2. Something like that. Okay? And the other one here, b. Okay? b to the y. Okay? y. Actually, it's just the same principle, but I forgot that this is already y. Okay? But actually, what in my mind is just the same. It's just the same reaction order. Only the different only is we need to use another variable. Okay? The principle is still correct, but the variable we choose is not really different. Actually, we need to use another variable. Sorry for that. The principle is just the same. How to compute. Okay? 3y is equals to 9. So, in order to make this 9, so we need to multiply this by 2 itself. That is 3 times 3 is equals to 9. Okay? So y is equals to 3. Oh, 2, sorry. This one equation. Okay. 3 raised to the power y equal to 9. So in order to get 9, you have to times 3 this 3 exponential 2. So 3 times 3 is equals to, so it will be equal. So y is equals to 2. Now, we have now y is equals to 2. Okay? Like that. So, we need now to substitute that one in our rate law equation. Like that. Okay? So, we have now the rate in our general equation here. Where's that one? This one. Oh my gosh! This one, use this one, Okay, but actually, we will correlate the two, the concentration A and concentration B with its corresponding rate of reaction A and B, okay? Now, this one. Okay, now, be careful. So, rate is equals to, actually, some books go directly with the constant, but I have to explain also why the constant will appear, okay? So, like this. Actually, this is rate, key. We need to combine the two, the A and B. Okay? So it will become now concentration of A raised to the power 1 which is the value of x is equals to 1 we solved already, and then times the concentration B, which is the y equal to 2 we solved already. It's here, right? Wala kasi yung whiteboard, kaya medyo magulo. My discussion is very, turbulent because I don't have the whiteboard and any, animation to make my discussion very clear. But don't you worry, the foundation is in my brain. Okay, then I have to just share with you, okay? Like this. This goes to 2. Like this. So R, putting 1 as an exponential is the same as don't put that 1. That's in chemistry. Okay, so K, A, B, 2. And X is equals to 1 and Y is equals to 2. Okay, this one. Okay. So R is equals to K times A raised to the power 1 based on the data experimentation we obtained times concentration B raised to the power 2. So K is equals to A times B raised to the power 2, in which our X is equals to 1, our Y is equals to 2. So this X is the reaction order in concentration A. This exponent Y is the reaction order of concentration B. So the overall reaction order 1 plus 2 is equals to 3, or something like that. So N is equals to X plus Y. So 1 plus 2 is equals to 3. If the question will say in the problem solving, what is the overall reaction order? So your answer will be 3. What is the reaction order of your concentration A? So that is 1. What is your reaction order of concentration B? That is 2. In which these numbers we solve that through algebra in the series of experimentation data that we gathered inside the laboratory. Something like that, okay? All you have to do is to, incorporate algebra in our brain somewhere in our discussion, communicate that properly to your discussion, something like that. Okay? Like this. Okay? Now, actually, the K should also be denoted as K1 over K2 is equals to R1 over R2. Okay? Or, so K1 over K2 can be simply written as K. Okay? Because these are all constant and there's no such complex in the chemical reaction that you have another reaction. It's only one single reaction to produce a product. So K1 over K2 is just equals to K. Okay? And R1 and R2 is just equals to R. Okay? That's why in here, in the general formula, no need to put R1 is equals to K1 like this. If you want to that make it individually, you can also get. But what I'm telling you, K1 over K2, constant in each reaction and reactant A and B is just equal to K alone. And R1 R2 is equals to R. Okay? Because the reactants are just single and produce other products. There's no such complications. 4 reactants, 5 reactants to produce how many products. There's no such like that. We have only 2 reactants. Okay? So it's gonna be like that. Okay? So there's no complication in our constant. Actually, we have K1, K2, R1, R2. But due to the proportioning, R1 over R2 is just equal to R. And K1 is equals to K2. Okay? K1 over K2 is equals to K. Because that's the same. Ratio and proportioning. But you cannot proportion if they don't have the same quantity. Something like that, huh? Okay? That's the rule for ratio and proportion in mathematics. Do not do that if it doesn't have the same or similar quantities. Okay? Like that. It should be basing on the similar quantities. In here, similar quantities. Like that. Okay? So, if you want really to break down, so let's say R1. Okay. R1 is equals to K1 A raised to the power 1. Okay, equation. Ilang equation na ito? Equation 6. Equation 5, sorry. Equation 5. Okay. Equation 6, R2 is equals to K2 B is to the power 2. Like that. Okay? Okay, then R1, R2, you have also this like one, and then you can combine that one to obtain same like this. Okay, as I told you. Okay, like that. Or stated differently, okay, R1, okay, K1, A1, B1, charot. Okay, then like this, 1, 2, okay. So it's just the same. The K1 and K2 is just the same. The A1 and A1 in the derivative is just the same. So just put that as A alone, right? Okay? If you put R1 over 2 as R alone, the same thing, K1, K2 is also K alone. And A1 and A2 is A alone, and B1 and B2 is K alone. I'm just showing you why we come up for this R. Since we know we have two equations, where the other equation goes, something like that. Just because of this ratio and proportion. This one. Okay? Like that. Now, we go now to the relationship. This is also important because some of the problems also and questions will be like this also. Now, if you increase the rate constant of the equation, K, what will happen for your chemical reaction? Okay, your chemical reaction will become faster. Okay? If there is a small value of K, which is your rate of equation constant, your reaction will be faster or higher. So we can say that automatically that, okay, K is inversely proportional to your rate of chemical reaction. Okay, or rate of law of chemical reaction. For example, if the problem gives you a very small K, it is expected that you have a higher rate of low chemical reaction or rate of chemical reaction or faster chemical reaction. It's going to be like that. Don't be confused with the terms. Okay, again, if you have a high constant, your rate of reaction will become slower or lesser because inversely proportional with each other, not directly proportional with each other. So the relationship is inversely proportional with each other. K is 1 over rate of the reaction, small letter r. This one. Bear this in mind. Okay? Because somewhere along your computation, you get the final answer, then it's not also logical. Oh my God, why this is higher? Based on my theory, it's become big. So, you have wrong solution. Okay? So, you need to review again. Sometimes it's not enough to get the answer. You have to think also, oh my gosh, why it's become low and my initial reaction is like this and why it's still lower and I have a very high K. Oh, ganon. It's not enough to solve that, you know everything, the formula, then you go like that. There's something wrong with your theories. It doesn't match to your final answer. The theories govern on that particular topic. Okay. I think that's most the usual mistakes of some examiners, including me. Okay? Especially when we get in hurry. Okay? Like that. We don't examine anymore. That it's gonna be logical, reliable, or valid to get that answer, even though our solution is, we feel it's correct because we're using the correct formula, but it is not really that enough. You have to, evaluate the relationships. All chemistry problems like that, even though higher chemistry, or even unit operations, something like that also. Bear that in mind. The relationship could either be directly proportional or inversely proportional so that you can determine your answers high, low, big, small, like that. And it should be valid. Okay? Something like that. So, this is enough for the overview or the basic foundation of chemical reaction engineering or chemical reaction kinetics. Okay? In my next in live streaming, I will be able to give specific examples of the chemical reaction and we apply this basic interpretation of this chemical reaction engineering and then bingo, we can solve simpler to average problems for this chemical reaction engineering problems. I cannot assure you difficult problems because me also, I find difficult this topic and subject when I was in my college days. Okay? Like that. I am assuring you, you will learn a simpler to average type of chemical reaction engineering problems only. Okay, the difficult one, never mind. Okay, as long as we have the, the basic foundations. As I told you earlier a while ago, okay, the examination, bodies will not give a lot of difficult problems because all will fail it. Okay, that's why it's called regulating or regulated commission, something like that. It's impossible. They will give different, all difficult. No, it's not. It's our own mind only that tells us, oh, it's difficult. Oh my God, it's the psychological effect. But actually, it's more on simpler to average. Only small are difficult questions. Okay, like that. Okay, only regulated, but not all difficult. Okay, if that is the case, nobody will pass. Okay, if all are difficult, just try that to inculcate in your mind. Okay, all types of examination, not only are limited to PRZ board engineering examination. Okay, or engineering licensure examination. Okay, thank you so much for listening. If you think you really get a little bit of information out of my discussion, then you can click the notification bell from some newest updates of I Am a Senior Eternal Voice. And then if you are not subscribing yet my YT channel, then it's about time to subscribe. Okay, thank you so much for watching, guys. See you later. Bye-bye. God bless everybody.